Assalamualaikum and hello everyone. In this video, we are going to learn in details about the thyroid cancer. This video will be divided into a few parts. The first one is the brief intro about the thyroid cancer. The second one is the causes of the cancer. Next, mutation of genes and chromosome. Activation of genes. Last but not least, the pattern of inheritance. Based on the paper by Carlo et al., it stated that in most areas of the world, thyroid cancer incidence has been appreciably increasing over the last few decades, whereas mortality has steadily declined. In most countries, a steady increase in the incidence of thyroid cancer, mainly papillary carcinomas, was observed in both sexes. The declines in thyroid cancer mortality reflect both variation in risk factor exposure and changes in the diagnosis and treatment of the disease, while the increases in the incidence are likely due to the increasing in the detection of this neoplasm over the last few decades. The causes of the thyroid cancer.
BRCA1 and BRCA2 genes are suppressor tumor genes which produce proteins that are used by the cell to make repairs to the DNA molecules that have double-stranded breaks. The genes are only a problem when they contain abnormalities or mutations when they are passed down from the previous generation. Therefore, cells are more likely to develop additional genetic alteration that can lead to cancer. People with abnormal BRCA1 and BRCA2 gene have an increased risk of developing thyroid cancer. BRCA1 gene carry high risk of mutation to thyroid cancer compared to BRCA2.
Activation of genes.
In most cases, about 70% of thyroid cancer happen when mutation of BRAF, RET, or RS were activated. Alteration and change in gene that would release inhibitory constraint of the catalytic domain of BRAF lead to kinase activation. However, research shows that the activation of BRAF by chromosomal rearrangement that lead to N-terminal translocation. Besides the uncontrolled activity of various signaling pathways, including MPAK, E13K, AKT, were molecular phagogenesis of thyroid cancer. The progression of thyroid cancer is a process of accumulation of genetic corresponding dearrangement of signaling pathways.
The pattern of inheritance of thyroid cancer.
Thyroid cancers occur approximately 3 times more frequently in women than men. Although the reason for this difference is unknown, women also tend to develop this cancer at an earlier age, which is about 40 to 50, than men, which is about 60 to 70 age. The risk of developing thyroid cancer is estimated to be 6 to 7 times higher for people with first-degree relative with thyroid cancer. A first-degree relative is a parent, brother, sister, son, or daughter. Some people have gene changes that cause syndromes called MEN2. MEN stands for multiple endocrine neoplasia. People with MEN2 have a higher risk of some types of cancer of hormone-producing glands, including thyroid cancer. Not only MEN2 syndrome, family history with MTC that caused by abnormal RET oncogene also increases a person's risk. MTC stands for medullary thyroid carcinoma. However, not everyone with an altered RET oncogene will develop cancer. Blood tests and genetic tests can be detected the gene. A family history of goiters also increases the risk of developing papillary thyroid cancer. Besides, a family history of precancerous polyps in the colon, also called the large intestines, increases the risk of developing papillary thyroid cancer.
The gene and chromosome mutation in thyroid cancer.
The abnormality of RET oncogene that pass to children may cause MTC. Once the altered RET is identified, a surgery to remove the thyroid gland is suggested. However, not everyone with altered RET oncogene will be developed into cancer. The identification can only be detected through the blood test and genetic test. The genetic alteration in thyroid cancer involve gene mutation, gene translocation, gene amplification, aberrant gene methylation, and several altered pathways at molecular level. Gene mutation leads to protein mutation and causes the continuous activation of the series of genes. It also may affect the nucleotide around codon 600. Mutations or deletion of the gene of the tumor suppressor gene are the genetic alterations that lead to activation of cell signaling. On the other hand, the aberrant gene methylation is a silent mutation that was found to be associated with hypermethylation. At several tumor suppressor genes, all the alterations will end up with the activation of cell signaling that synergize and amplify the oncogene activity of the cells. Protein that attach to the extracellular matrix is crucial for phagocytogenesis of thyroid cancer. ECM also responsible for the behavior of the cancer cells such as viability, proliferation, adhesion, and mortality.
So that's all from us and hope you enjoyed this video. Bye bye and Assalamualaikum.